bring up next Matt Gilmore from Consumers Energy. More than 11 years at Consumers. He's responsible for a very critical aspect, the enterprise information models across a number of different areas. So crucial to getting the right kind of system that can be foundational for your future growth. He's a contributor to the Open HAN systems requirements specification, and he's currently chairs both the Smart Grid Network Task Force as well as the IP Suite Working Group. So we're lucky to have Matt here. Matt, take it away.
Thanks, Jesse. So I want to give you a quick background of what Consumers Energy looks like in Michigan. When you look at the yellow and the green areas of the map, that's where we have electricity customers throughout the state. The blue areas are where we have gas customers throughout the state. Combined, we serve approximately 6.5 million people in Michigan. We employ about 8,000 employees throughout the entire state. We have service in all 68 lower peninsula counties. And if you're curious, on the east, you'll see Detroit Edison's territory in the gray. And if you look on the southwest, you'll see American Electric Power's territory and a little bit in the southwest corner. At Consumers Energy, we're looking at investing $6.4 billion in Michigan over the next 5 years. Obviously, smart grid is a large investment part of that. A lot of other aspects of that are renewable generation and other projects that are focused on the economy of Michigan. I want to talk a bit about our smart grid strategy. We're not a recipient of any grant dollars to go out and implement smart grid technology, so we've had a guiding principle that we're going to prove that smart grid works before we invest in it. That has a high focus on lab testing. We look at things like interoperability, scalability, reliability, and we take our learnings from the labs and we verify them in pilots. We're also following a standards-based approach. We believe wherever possible, all elements shall be standardized within the smart grid ecosystem. Because of that, we will get economies of scale. We'll take advantage of best practices that many in the industry who've gone before us have done. We want to hop on and learn from what they've done over the years of experience. Some of the challenges that we've had at Consumers are, as I showed you in a couple slides ago, 1.8 million electric customers over 29,000 square miles of service territory. We also believe that all customers shall have the same level of functionality. So what we offer to our urban customers, we shall offer to our rural customers no matter where they are. We also have a multi-year scheduled deployment. This is particularly challenging because we're looking at approximately 8 years from our first meter installed to being finished. And I think, as most of you know, technology evolves rapidly, so we need flexibility to be able to handle that scenario. On top of that, the communications technologies themselves are evolving and becoming more standardized. We're also looking at the challenge of having a meter last 20 years as it's deployed as an asset before we can completely depreciate it. This is a key challenge when you look at talking about cellular networks, especially when you look at, I'm buying the equivalent of a cell phone, I expect the last 20 years. Here's an overview of some of the vendors that we've tested at Consumers Energy. We've looked at mesh solutions from Silver Spring Networks, Landis & Gear, Itron, Elster, and Trilliant. We've looked at point-to-point solutions with Census, SmartSync, and GridNet. With all those technologies, we looked at following business use cases. We looked at, from the AMI side, we looked at meter reading. We looked at service switch operation. We call that remote disconnect in some people's dialects. Demand response, dynamic pricing, load control, electric vehicles, AC, air conditioning cycling, and whatever else we come up with. We also did quite a bit of extensive research with distribution automation, particularly in volt bar control, fault detection, isolation, and reconfiguration. We've looked at lots of different scenarios with lots of different technology and devices out there. In addition to the business use case test, we also looked at what would a day in the life be like if we were to deploy one of these systems. We looked at network bandwidth. We looked at network convergence. When we talk about power outages and things that can go wrong in natural disasters, we looked at how long did devices take to reconfigure, how did it work, how did it behave. When I had a crew in a neighborhood, if they were to re-energize a line, how long would it take for the system to come back up to help me find nested outages? We also looked at when you are reading meters 4 to 6 times a day, what information do you need to know to properly operate the system? We found that we needed to know what kind of signal strength we were getting from meters, how good was the coverage on certain meters. If it were a mesh system, we looked at, could we figure out how many meters were on a particular route, how many hops were they taking to get where they needed to be, because that impacted how long it took to do reads in certain areas. and just generic troubleshooting. So what we found from our testing was that most, if not all, the vendors met the business requirements that I talked about, all the AMI and DA use cases. Less of the vendors we tested met the operational requirements. We found no matter what technology we looked at, particularly in the mesh side, that installing, maintaining, operating the equipment was expensive. And we also found, due to the uniqueness of our territory, and as I showed you in the first slide, the public carriers offered sufficient coverage within our territory. Some of the lessons learned from our testing experiences and our pilots were operational expenses over the life cycle of the solution were significant no matter what technology we used. Obviously, it was different between the vendors, but either way, they were significant. Because the technology continues to evolve, layered architecture is best suited for evolving communications technologies. At a minimum requirement, at Consumers Energy, we're requiring technology to have at minimum support for Internet Protocol. Having Internet Protocol, we also understand that multiple communications technologies and vendors will be needed. As Brian mentioned from Sprint, not everyone has coverage everywhere, and strong relationships with vendors where you have roaming agreements and the ability to upgrade your network communications technology over time is crucial. Meanwhile, leaving the upper layers of your solution untouched. The other lesson learned we found was in our pilots, building, maintaining, and operating a communication network wasn't pleasant. We didn't have core expertise around that, and there's a lot of learnings that we had to do. Think about putting repeaters, access points, collectors on utility infrastructure. Those were things that we did not have experience with. So because of a lot of the operational challenges we saw, Consumers Energy arrived at Cellular as our main technology for what we're going to deploy for AMI. The advantages we found was the ability to select multiple carriers. Within Michigan, using AT&T, Sprint, and Verizon, and a few other carriers, there's more than sufficient coverage for what we need to do. Also, we don't need to build the infrastructure. As we have a 8-year deployment, it's very helpful to us that we're able to deploy the AMI technology at the biggest bang for our buck without having to build the infrastructure. That gives us a lot of flexibility in our deployment. We also avoid network vendor lock-in, particularly on CDMA technologies. You can literally go back and forth with agreements with carriers between Sprint and Verizon, for example. And it's standards-based. I don't have to worry about when I deploy a meter, is this device interoperable with GSM or CDMA? There's well-established labs and industries that certify that. And briefly, some of the disadvantages that we had with this approach. We do have a problem with meters that don't have coverage. We will need to figure out how to get repeaters to them. And also, I think Consumers Energy is the largest utility attempting to do a rollout this large with a public carrier. While I'm confident we'll be successful in this rollout, there will be a lot of firsts that we run into as a utility doing this approach. With that, I'd like to hand it back to Jesse for questions, and thank you for your time.